Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, future engineers, subscribers, and viewers. There is another problem in calculus. I hope that through this video and the solution, you will be able to develop your skills in solving problems in calculus, which will make you better engineering students in the future and hopefully better engineers. So here is the problem. By the way, if you want to anticipate the solution to this video, you may do not look at the solution. You just copy the problems and solve these problems by your own. So for part A, find the slope of the tangent to the curve y equals x cubed minus 4x plus 1 at the point where x is a. Then B, find equations of the tangent lines at the points 1, comma negative 2 and 2, comma 1. So when x is 1, y is negative 2, you just substitute into the equation of the curve. And when x is 2, y is really 1. Then graph the curve and both tangents on a common screen. For the second part, it's the same. The curve is 1 over square root of x. And same instructions. Points now would be 1, 1 and 4, comma 1 half. So for 1a, y equals x cubed minus 4x plus 1. The derivative is 3x squared minus 4, which represents the slope of the tangent to the curve. And in particular, when x is a, so 3 times a squared minus 4. So that's the answer to part 1a. Then for 1b, particular slopes at this point. So slope is 3 times 1 square minus 4, so negative 1. Then we use point slope form. Y minus y1 equals slope times x minus x1. So y minus negative 2 equals slope negative 1 times x minus negative 1 from this point here. So y plus 2 equals negative x plus 1. So the first tangent has the equation y equals negative x 1 minus 2, so negative 1. Then for the second, this is the point 2 comma 1. Slope is 3 times 2 squared minus 4, so it is positive 8. So y minus 1 equals 8 quantity x minus 2. So y minus 1 equals 8x minus 16. The second tangent is y equals 8x minus 15. And for the graph, if you're still new, so this is cubic. It looks like that. The curve looks like that by experience. Then we plot some points here. Uh, if it is calculator aided, it should be calculator aided for engineering students. So generate these points, verify, and for the second, for the tangents, this should be the points. And sketch the curve. So this is it for the curve. So as mentioned, it looks like that. Then these are the points. Transfer these points on the curve. So we have negative 2 comma 1, intermediate points negative 1.5 comma 3.625, negative 1 comma 4, negative 0.5 comma 2.875, 0 comma 1, 0.5 comma negative 0.875, this one, then 1 comma negative 2, 1.5 comma negative 1.625, 2 comma 1, and so on and so forth. Then this is the smooth curve, And for the slopes, we have y equals negative x minus 1. The y-intercept is negative 1. So at 1 comma negative 2, this is y equals negative x minus 1. And at 2 comma 1, the tangent is as shown. So y equals 8x minus 16. So that's it for the first problem. For the second problem, find the slope of the tangent to the curve y equals 1 over square root of x at the point where x is a. Then find equations of the tangent lines at the points 1, 1, 4, comma 1 half, and graph the curve on both tangents on a common screen. So y equals square root of x, the derivative, if we use power formula, we can transform this into x to the negative 1 half. So m is dy dx negative 1 half x to the negative 1 half minus 1, so x to the negative 3 halves. Simplifying and transforming, negative 1 over 2 x to the 3 halves, replacing x by a. So slope of tangent dy dx is negative 1 over 2a to the 3 halves. Then 2b, we substitute x or a is 1. So negative 1 over 2 times 1 to the 3 halves is negative 1 half. Then apply point slope form, y minus 1 equals negative 1 half times x minus quantity x minus 1. So y minus 1 equals negative x over 2 plus 1 half. Simplifying, the tangent would be y equals negative x over 2 plus 3 halves. So y equals negative x over 2 plus 3 halves. This is the answer to 2b. 2a negative 1 half slope. So y equals negative x over 2 plus 3 halves. Then for the second tangent, y equals negative 1 over 2 times 4 to the 3 halves. So that's negative 1 over 16. Then we'll have the point slope form, y minus 1 half from this point here equals slope times quantity x minus 4. So y minus 1 half equals negative x over 16 plus 1/4. Simplifying, the second tangent has the equation y equals negative x over 16, 1 half, 1/4 plus 1 half is 3/4 plus 3/4. We then sketch the curve. Take note, it is 1 over square root of x. So when x is 0, it is undefined. And when x is just to the right of 0, it is very large, so positive infinity. When x is 1/4, we have 2. When x is 1, 1 also. When x is 2, square root of 2 over 2. 3, square root of 2 over 3, 4, 1 half, and so on and so forth. It approaches the x-axis. When x approaches infinity, y approaches 0 above or 0 from the right. So next we show the tangent at the point 1, 1, which is this. And the equation of the tangent is negative x over 2 plus 3 halves. The y-intercept is 3 halves, so it crosses here as shown. So y equals negative x over 2 plus 3 halves. Then for the second tangent at 4 comma 1 half, it is negative x over 16 plus 3/4. So the y-intercept is 3/4. It must cross that point there. And this is the second tangent, y equals negative x over 16 plus 3/4. So that's it for this video. I hope that you were able to follow the explanations and the solutions. And to those who attempted to solve this problem, then I hope that you also got the answers.